How's it going, everyone? So what I want to cover, I know we only have an hour. I want to leave a little room for questions, but I want to get everyone familiar with our single phase dimmers, and if we have time, our three phase dimmers. Just basically the flow of power internally, where it goes from your base input all the way to the Edison or Sockapex outlet, just so where the test points are at, where the voltage should be at. I'm going to try and touch in as much as I can. Feel free to type in questions. I'll try to get to them as we go through. Just so everyone's aware, I'm going to be kind of discussing everything in a flow from input to output, and then I'll go back and review based on common failures that I see in the field or failures that I see as things come back from from rental or sales. So we're going to go ahead and get started. Let me flip this around. I also had typed up something for everyone to kind of use as a reference. I think Gary was going to drop that into the chat. That way everyone can have that for later. Feel free to make notes on it, download it. It's just basically a reference point for what I'm going to go through, as well as assisting you later on. So what we're going to do is we're going to start. I have here a 10 by 1.2. It is fully opened up, so y'all can see exactly what's going on in there. I know it looks like a bit of a bundle of wires, but at the end of this, I'm sure you'll understand what everything is. So what I want to begin with is, like I said, the flow of power. And what that means is all the way from your base input to the receptacle in the front, what happens, where the power goes, what it connects to, what the break points are or test points might be. And what that begins with is your 100 amp base input. So you can see here, this is where your base input will go in. You have your hot, your neutral, and your ground connections. Your hot being this red little tab here, neutral in the center, and ground is just going to connect to the bottom of the chassis on the fan side, on the other side of this base here, as well as the face of the dimmer to one of the receptacles. And I know we're doing a little freehand video, so bear with us, but we're going to try and get as best of a view as possible. So basically what we're going to do is we're just going to go through. We got 120 amp base input. And what's going to happen there is you're going to have 2 gauge connections to this distro block. So your distro block is going to be your first point of connection. Now, what that looks like is something like this. This is a 3-pole distro block. So this is something you might see in a 24 by 1.2 or a 3-phase dimmer. What you're going to see in this single phase dimmer is essentially this portion here, a single pole of distro. And what that is a 2 gauge input on this side, which is where these thick wires are going to connect. And on the opposing side is going to be 4 little circular inserts. And that is where the 12 gauge wire that is running to all of your outlets are going to be slid in. So it's going to be 3 wires per slot. Now that is going to get secured by a little flathead screw right here. And I want to mention this because over the years, as I service these things, I may replace a wire, whether a receptacle got burnt out or something happened and I need to replace the wire or take it out or put a new one in. When tightening these down, you have to be very careful not to over tighten them. It is stranded copper wire that we are dealing with here. So we don't want to over tighten them because you can break the stranded copper and essentially lower the gauge of the wire, which will create more resistance, more heat, and we don't want any of that going on. So be wary when you're torquing this down. There is a torque setting on the side, so just reference your torque settings there if you use a torque tool. Otherwise, just give it a nice hand tight. You can give it a tug test if you do replace it. Also, I want to mention that I do zip tie everything together right at the end, all the 12 gauge wires right at the connection point, just so it makes it more solid when going through it. So after I install everything, I'm going to give it a little quick tug test, just make sure nothing pops out. I just wanted to mention that real quick. Moving on, we have from the power input to the distro block, your line or your black wires are going to be independently connected to each corresponding breaker. So these breakers are 10 amp breakers per channel. Each line will connect to it because no matter what dimmer you have of our Ratpacs or any dimmer, you have to have preliminary protection. So your first point is always going to be your breaker. Now this breaker has 2 tabs on it. It's going to take the power coming in from the distro block, and then the other tab is going to run through your choke to your relay. So if you don't have a breaker that is, let's say it's damaged, you're not going to get any AC voltage or current going to your relays, and you won't have any output. So keep that in mind. Here is a view of the 2-tab breakers that we use. They are dual state breakers. Now, what that means is in order for this breaker to trip, it's going to require about 10% of the overcurrent and a temperature rise of, I forget the degrees, but it would take a few seconds if you plugged in, since this is a 1200 watt dimmer, if you plugged in a 2K, it would take a few seconds for it to warm up and then trip. So be sure that you understand that even though you plug in a 2K, it may come on slightly, it will eventually trip and you will eventually damage the breaker and it can go soft. So a quick and easy way to check your breakers, since it is your first point, is just set your meter to continuity. Like I have here. Continuity looks like a little speaker. It's essentially going to send signal from one probe to the other. So as I connect this, it'll show 0 resistance. And all you want to do on your breaker, which I'm sure many of you have already done, is just set one probe on one side and the other on the other tab to make sure that you have good flow and good continuity between or through the breaker. Now, I don't know if everybody had the write-up that I have, but I have some notes there just checking on how to check the breaker with the multimeter as well as the temperature things I just mentioned. The next step would be, the next flow, I should say, would be from the breaker through the choke to the relay. So all of our 10 or 20 amp dimmers will have the same style choke. It's a little circular donut type of style. One thing to note, which is very important, is here in between the chokes are fiberglass rods, or fiberglass discs. These must be installed. What can happen is if for some reason somebody forgot to install these and you notice that, what will happen is if this isn't there, the vibration, they are insulated, but the vibration as is on the truck and as it's getting transported will eventually rub through the insulation and you'll get a short here. And that'll be a nice big bang, and which will definitely turn some heads and you'll get a bunch of char marks here. So if you have a dimmer that comes in and it's saying no power or short or some type of big fault, just take a quick look at the discs, make sure they're there. If it failed, it would be very obvious. There would be a big bunch of black char burn marks here. And then essentially at that point, you would have to replace all of these surrounding chokes. We'd probably just send the entire assembly. Again, I'm going to go back and go over more test points. I just want to continue forward. So the next, let me turn this around. After it goes through the choke, the next point is the relay. Now, this is where 99% of your troubleshooting is going to happen, because this is the biggest failure point that we see as far as QC goes. I have a relay here that I can show you that's outside. And what that looks like is so this is a dual solid state relay. That means there are 2 channels per relay. So on this side, you'll see this is labeled channel 1 and channel 2. This is your 4-pin DC control. So these 2 pins are going to be your DC control for channel 1. As you can see, the outside pin is marked positive and the inner pin is marked negative. So later on, when I show you how to check the voltage and test to make sure you're getting good signal, these are the 2 pins you're going to reference for channel 1, and these 2 are going to be the pins you reference for channel 2. Now, these connection points, this pin, or it actually doesn't matter which way you connect it, but the bottom is usually what we connect from the breaker to the relay, and then this tab here will go from the relay to the output. So as you get units in and their channel-specific failures, I always like to go ahead and take a quick look at your relays because of all the connection points that are there. It is very easy, if you look right here, if they did not glue the pins properly, it can slide off. So we put these on, add a little bit of hot glue to keep it secure because there's so much vibration during transportation. However, that sometimes doesn't always work. So what I want to do is open this up, check the 2 tabs here, as well as check the 4-pin and make sure it's connected. Now, moving forward, let me turn back around. We are going to go over some of the failure states of the relay. So if you've ever dealt with a Ratpac that had a failed relay, 99% of the time when the relay goes out, what's going to happen is the output goes full. So if a relay fails, it fails closed because it's the gatekeeper. It's allowing how it dictates how much current is going to the output based on your DMX value. So when this fails, essentially what it does, it just fails closed and you get 100% of output regardless of DMX control. So as soon as you plug in that Bates, if one of the channels goes to full, even without DMX control, or there's no panic or bump function whatsoever, then you know for sure it's the relay. So I wouldn't even go further into trying to figure out, why that channel is hot. Just from my 10 plus years at Ratpac, I can tell you for sure it's going to be the relay. And all you got to do to check that, if you wanted to be sure, is take channel 1. So if you come here, you can take channel 1 connections, remove them, pop it on channel 2, and then bump that in the front to see if the failure follows the channel. So if the relay failed, it should not follow the channel. It should be stuck, or excuse me, it would follow the channel because it would be stuck to that specific section of the relay. So as you move the tabs, now the failure wouldn't be on channel 1, it would be on channel 2. So I hope that makes sense, and we'll go into that a little bit more. But that's one of the most common failures of your relay. So make sure to keep that in mind. My notes kind of go into that, and I'll go into that a little further. Another common failure is your DC connections. So here is your control. This is what's going to dictate, how much output you're going to get. Now, like I said, they do slide off if they are not properly secured, but they are also crimped by hand using a crimp gun. So I don't know if every repair place has a crimp gun. This is the crimp gun we use. And essentially all you would do is take a tab like this, slide it in, and then run it through the crimp gun and make sure that it's properly crimped, all of them. So what you'll see, if you can try and zoom in on here, is there's a little nipple, a little dimple that happens when it's properly crimped. If it's not crimped properly, you'll see the insulation of the wire popping above these little metal tabs here. So what you want to do is, if you don't have a crimp gun, you can use something like a flathead screwdriver, not too sharp. The duller the better. You can always put a little piece of E-tape on the tip if you'd like, and just press down moderately on the top of the wire to push that into the crevice there. Because what it does essentially is it takes the insulated wire, and as you crimp it down and push it down, those two metal tabs will strip the insulation, and then the copper will make contact underneath. So if you have channel specific issues, and we've gone through the steps that we're going to go through in a minute, and you're still not sure, why that channel isn't responding, take a look at the 4-pin, make sure that that insulation is nice and pressed in. You should be able to see the metal tabs in there. And I apologize if we can't really focus on it, but I will send pictures and diagrams to everybody in this chat as well after, including the material that I wrote up. So that's one other thing on the relay. And of course, the final connection point from the relay is back out to your output. So this is the Edison 10 by 1.2. What you're going to see is, if the relay fails, of course, it's going to be hot. So if I plug in a light bulb, it's going to be on at 100% no matter what. Now, there's times where the channel is dead and it's non-responsive. Now, that is going to involve a little bit more troubleshooting, because that is most likely either a connection that came loose, or the DC voltage coming from the controller is not properly, being sent to the controller, or the connection on the actual 4-pin is bad. So what we're going to do right now on this single phase dimmer is we're going to go through a couple of steps. We're going to go through the most common failures. And we'll come to the control board. Actually, while you have it in hand, what we'll do is review the control board real quick. So before I go into the troubleshooting steps, I want to give you guys an overview of the controller, how it's powered, what it connects to, what it powers up. Because besides the relay, a lot of your troubleshooting, when you get a VO unit, is going to be right here as well. So what you see, lift this up a little bit. What you see here is our 12-channel controller. This is going to be in our 10 by 1.2s, our 6x2.4s, and our 10x1.2, 6x2.4s, and our 12x1.2. So all of our single phase 100 amp Bateson dimmers will have this controller. And if you have the old larger 3-phase controller that reaches all the way to these PEMs, then let us know, and we should update those controllers as soon as possible because they are not LED compatible. I would imagine not anybody has them anymore. They should have been outdated many years ago. So here we have 12-channel controller. This is our 9-pin power input that I will be referencing in a minute as we go through some troubleshooting steps. So as I say, make sure the 9-pin power input is properly connected and we're reading voltage. I'm referring to this here. So this is connected directly to the distro block. There's a 12-gauge wire that runs from the distro block through the trip switch, which is just a safety switch that cuts power to the controller when this door is open. And then from that trip switch directly to your 9-pin. So if you have a unit that you get back and the power, you have no power whatsoever, you of course want to make sure that you have proper distribution and proper voltage present at the distro block, and then make sure that you have continuity all the way through the trip switch to the 9-pin, or you can use your meter with the power on if you wish, and measure 120 volts at pins 1 and 2, your line and neutral on your 9-pin input. Now, if you have voltage there, but the power, your board is still not powering up, take a look at this fuse here. So this fuse just has a couple dabs of hot glue. It can pop right out. You can pop this out, check with your meter continuity that it hasn't been blown, because if this is blown, then you will not get any power to the rest of the board, which will result in a dead dimmer. Besides the power input, we have your fuse, we have our dip switches, which control multiple functions. We're not going to get into that now. You can read that on the vinyl of the outside. We have our thermostat connection here. Now, just to show you, the thermostat is here on the relay, or excuse me, on the relay panel next to them. So if you have a dead dimmer or no power, another thing to check would be your thermostat, because how this works is if it heats up enough, it'll cut power to the entire dimmer until normal operating temperatures are reached. Now, these both are normally closed, or excuse me, normally open. So if they fail, you would meter them and they would have continuity. So they should never have continuity, as these are normally open thermostats. This thermostat is for the fan, and all that does is allow for proper cooling when it heats up enough. So if you have a full load on the 10x1.2 and you're running it for an hour or two, you might get enough heat where the thermostat will trip and say, okay, let's start cooling down. This will not cut the power to the controller. Now, if the heat continues to rise, and I forget, it's something outstanding, I wouldn't imagine you would ever reach it. But if it did reach that specific temperature, then this thermostat would trip and tell the controller to shut off completely until it reaches normal operating temperatures. So keep that in mind as well if you have a unit that is labeled dead or no power. Coming back this way, on this side, you have your DC outputs. So you have your AC in on the other side, and here you can see you have your DC. You have 12 volts DC and 5 volts DC. And what these are doing are supplying your DMX card, your wireless card, your display board, so all your panic functions, your bump button functions, all of the things you need on the face to get the channels functioning locally are going to be supplied with the voltage here. So as we go through more steps, I'll show you that in a second. This is your 3-pin DMX. So if you have a unit that says, okay, I got everything's powering up, everything looks good, my panic function works, I can even bump individual channels, but as soon as I plug my Swiss on in, I'm not getting anything. Well, you want to make sure that your DMX is actually getting to its destination. So you can see it's labeled DMX. I don't know if you can read it here. It's on this side. But what you want to check is this 3-pin connection from here to your DMX IO board, 3-pin connection right there. It is also labeled DMX on the top. It's kind of hard to see here. But what you want to do is ensure that not only are they connected, remember, we do have crimps that can go out. So you want to make sure that you got a nice dimple in there, make sure it's crimped correctly. And if you're not sure, you can always do a continuity test. I'm not going to do it now, but get your meter, check black to black, red to red, brown to brown. And that's always the color reference: black, red, brown, black, red, brown, black, red, brown. And these again will be in the notes that I give you guys and gals. So be sure to save those and reference them. Moving forward, we have our display board commands, which is right here. So if you don't have any panic function or your bump buttons aren't working, your blue and orange connection here, which you see is labeled display board, will be in charge of the actual commands taking place and affecting the output. These three here are our address control connectors. So you can see they have hundreds, tens, and singles. Now this is actually a not so common failure point, but it can be very troublesome when trying to figure out what the heck's going on if it's related to the address wheel, because you may have specific channels that are not working, or they say they're not working, when in fact they are working. It's just set to a separate channel. So you're trying to control channel 20, but channel 200 is going on because one of the address wheels is not properly crimped, or it's halfway seated or not connected properly. So be sure when you do your troubleshooting, it's something that I like to do. I always send DMX to all channels if it's a channel specific failure, to make sure that, okay, there really is no DMX input, or it may be something like it is getting DMX, but it's just the improper channel. So hitting the panic function or sending all channels, DMX to all channels, is a good way to verify that the failure is actually in the dimmer and not with the address wheel. Now these two connections here, if you can see on the board, these are your output DC control harness connections. So this is what connects to the relay, the 4-pin relay that I mentioned earlier. On the board, it'll tell you, it'll reference output 1 through 6 and output 7 through 12. Now you always want to be sure that you don't swap these, because you're going to send it out and then people are going to be trying to bump channel 1 and channel 7 is going to come on. So if you do have an issue where it was repaired and maybe somebody accidentally swapped it and channel 1 is bumped and you're getting channel 7, it most likely is this harness. So you can go ahead and just pop it out, swap it, and be on with your day. Now, the control DC portion that I had mentioned, how that works is we have something like this. So this is connected here. And then what happens is we take the red wire, which is our positive for our DC power, slap a barrel connector on there, and then split that up to the remaining, to use for the remaining 6 channels, because the 6 channels are color coordinated in sequence. So channel 1's negative is black, channel 2's is white, 3 is gray, 4 is purple, blue, green, so on. And only 6 channels. So we don't use the yellow, orange, and brown colors on our control cables. And this is across the board, no matter what dimmer you have. So it's the same test procedure for each of it. But yeah, the positive is your red, the negatives are color coded in sequence. So as you're metering, if you're metering channel 1, you would meter between the red and the black. If you're metering channel 4, you would meter between the red and the purple, and you get the point, so on. So I'll show you all that in a minute. I just wanted to describe what this rainbow of cable is actually doing. As I mentioned earlier, we have a trip switch here. Now this is a safety switch. So as you're servicing the unit and you open the door, the switch will disengage and this will cut power to the controller. This doesn't happen often, but it does happen sometimes, where the trip switch just isn't fully engaging. The door will close. As you can see, maybe you can see behind this trip switch, there's a little button that engages here. So what happens is if it doesn't engage, then the door will close and it halfway engages. You won't get any power to the controller. So what I like to do, just grab it, give it a little bend. It won't break. It's very sturdy. And then it'll just allow for more pressure when the door is closed to make sure that that power is going through the trip switch and getting to our controller. So be wary of the trip switch. trip switch has gotten a lot of our rookie technicians kind of scratching their head like, what the heck's going on? You know, they are mechanical parts. They do fail. It's not a common failure, but keep that in mind. All right, moving forward, I want to go over the faceplate. Come back this way, Guillermo. So what we're going to do now is just review what's going on like we did with the controller on the faceplate. So here, as I mentioned earlier, we have our DMX 3-pin. So this is going to be connected to the 12-channel controller, allowing for DMX to get to our wireless card to then wirelessly send out to any receivers that are listening. Here are our connections to our 3-way switch, which is on the face of the unit that allows you to switch the transmitter into receive or into transmit or into off. And that is these connections here. So this is the power, this is the physical link button, and this is the switch. Again, this is the power, the orange, to the wireless card. The 4-pin, the color-coded red, black, brown, blue is your RF link button. So if you get power to your DMX wireless card, but you're pressing the RF link button and it's not responding, this is your 4-pin that you want to check. You want to make sure it's connected properly, it's seated on the pins properly, and that the crimps are fully seated down into that connector itself. And then we have the switch connections itself. So if we come to the face of the unit, this is our 3-way switch. If you're servicing these packs, at least once in your lifetime, you're going to be servicing these switches. Crew, they are manhandling anything and everything they can get their hands on set. So we got these breaking left and right. We have switched to a more robust, shorter, wider style of switch. So if you're still working with these, we call them baseball bat style switches, reach out to us. We can send you those switches. They're very cheap. We probably won't even charge you for them, but it's very important to have these switches working properly. And the reason why that is because if you have DMX being fed into your DMX IO board here, and you flip transmit or you flip the wireless card on, what you'll get is conflicting signals to the 12-channel controller, and that will result in a disco effect, if you will, a really erratic flicker. So as I'm troubleshooting, you'd be surprised, more often than not, people will call me and say, hey, this dimmer's not working, it's flickering all over the place. And I ask them, you know, what's your control source? Okay, using DMX hardline. Is your wireless disabled? And they look at it and they're like, oh, the light's blinking. Well, if it's blinking, that means it's enabled and you're getting 2 sources to the controller. So make sure if you're using hardline DMX to keep this position in the center. This is off, this is receive, and that's transmit. You want it in the center. The RF link button should not flash at all when it's in the center, and that will eliminate any possibility of DMX data confliction on your controller itself. Here up top, we have work lights. This was something that was only implemented in some earlier units. This is just a DC connection straight to the board. It is not mandatory. We've actually had some crew request to remove them. So if you own these dimmers and you get a lot of feedback from crew that, hey, the lights, I can't turn them off, I don't need them, they're too bright, you can just disconnect them from the board, or you can cut these off. It's not going to affect anything whatsoever. So I just wanted to bring that to light and mention it briefly. And now I want to get into common issues. And really, now that I've kind of explained a little bit what's going on internally, I want to review common issues that you would most likely run into when you get a unit back from rent. So the first common issue, let me get a sip of water. Before I move on to the common issues, just in review of the basic layout, does anybody have questions?
No, no questions.
No questions? Okay, we're gonna keep going. Common issues. If you have questions, just type it in the comments and we'll address them as we go. So the first common issue that you may run into is no power to the dimmer. So as we mentioned before, the dimmer or the entire box must supply power to the controller for everything to work. The controller is the brain of the operations. It dictates what turns on, what turns off, how it does it, at what timing, and all that good stuff. So what I like to say, or the first question I ask, do you have a power light? If your power LED is on, then you know that the controller is at least getting the supplied power that it requires to operate. So you know, okay, my controller has sufficient power, it's turning on, it's not that something else. If you don't have power and the dimmer's dead, then that just tells you you have to go back and you have to troubleshoot why the controller is not getting power. Now remember, the controller has a 9-pin connector. So I'm gonna go on this side. Can we get a close on this one? So the 9-pin connector is connected directly to the distro block. So we have this 12-gauge wire here going directly into this distro block that runs right into our trip switch. And the back of the trip switch has 2 tabs. This is only for the line. It has incoming line at the bottom and then outgoing line at the top. So when you engage this switch, it closes that circuit and it connects that line to pin 2 on our 9-pin input. Now the neutral is also coming from the distro block, but it is not connected to the trip switch. It just goes from the distro block directly to pin 1 of your 9-pin power input here. And this pin 1 is jumped to pin 8, and that's just for the fan. I'm not going to get too deep into that, but essentially you're only going to have 2 connections, 2 AC connections. Your power input, your line neutral here for pins 1 and 2, and then your line output for your fan. So this is running all the way through here to the fan. So you always want to reference your pins 1 and 2 closest to the top of the chassis, and that will give you your AC voltage. So if I have a dead pack, put my power on, I want to make sure that I have proper voltage. You can disconnect it, and to make it easy on yourself, you can just connect the tabs or connect the probes like so. Of course, you have to hold the trip switch and ensure that you're getting 120 VAC. If you're not getting 120, or you're getting anything lower than 114, 113 volts, you may run into some issues. This power supply is rated for a lot lower. However, we don't want to go anywhere near like 100 volts if possible. So try to keep it as 120 as possible if you can. Make sure that you check that. If that's good, remember earlier we referenced another failure point that would cut power to the controller, and that is the little brown fuse here. So that little brown fuse, same deal to troubleshoot it, pop it out, set it down, set your meter to continuity, check continuity, and make sure that it's not blown. I provide repair packages to all of our vendors everywhere. So if you want something as simple as fuses, maybe a couple 2-pin connectors because they're going out or whatever, what have you, just reach out to me and I can make sure to provide you with all the small components at no charge. So just let us know about that. And then power, we've checked distro block, we've checked trip switch, so we know that it's coming here. We've checked the fuse. Another reason that the controller could not power up is a short. So you can have a cable that's plugged into this controller where the polarity switched and it's causing a short on the controller itself. So if you've already gone through the pack and you know that the trip switch is good, you have good connection to the 9-pin, but it's still not powering up, but voltage definitely is there. I like to, just for me, I unplug all of the power connections on this side and on this side. And in some cases, if it is a short, the controller will come back on. And in order to figure out, which connection has the wrong wiring, I'll just plug them back in one at a time and see when the controller turns off. And then I can go and follow the wires, if you will, to figure out where that failure happened. Another thing, as I mentioned earlier, is the overtemp. So the overtemp will shut off the controller. And remember, there's 2 thermostats here. There's the thermostat for the fan, which is, this big one here. So this is your fan thermostat. This will never cut power to the controller. This is just tied into our fan right there. You can see the neutral and the line goes through the thermostat directly to the power block. Essentially what happens is when the dimmer is on, because our dimmers are whisper quiet, the fan is not on. And for most parts, you can operate it without the fan because of the large heat sink that we have. However, if you're in a hot environment or you're running it at full load for hours and hours and hours, of course, the temperature, the ambient temperature inside will rise, and this trip switch will eventually close, turning on the fan. If the fan is working properly, you should never have any issues with overtemp. However, if you do, that will be this thermostat here. So this thermostat will tell the controller completely shut off. Don't send any output to the loads because things are getting too hot and it's a fire hazard. So again, what I want to do, set my meter to continuity, come to my, I can bend these out here, come to my thermostat, hit one tab and the other, and remember, these are normally open, so I should not get any continuity, which I do not, which is good. If I have continuity, that means that this thermostat is damaged probably or broken, and you're having a closed circuit, which means at all times you will have the controller shutting off, and on the face over here, which is a dead giveaway, is your red overtemp LED will come on. So that only comes on when that thermostat closes and tells you temperature's too high, fire hazard, shut everything off, and give you a warning through this LED. Now, sometimes thermostats might just fail. I mean, it doesn't happen often, but it has happened before. So you might put in your baits and you realize, oh, you know, I'm only getting a red light. You can bypass the thermostat just for the sake of a test, and connect the two wires on the thermostat to ensure that it does power up at that point. If it does, then you know the thermostat is no good, or you check it with continuity and then just replace it. So those are the things that might come up when you have a dimmer that says no power. Now, no DMX would be another common issue that might pop up. So no DMX, there's a couple things you want to check. You want to check the 3-pin connection that I mentioned earlier. As you can see here, and in the notes, it's labeled J7. The color code should be exactly the same on this black, red, blue as it is on the DMX IO board, black, red, blue. If they are swapped or out of order, you will get no DMX. And one thing I want to show you that I think every technician will love is you get a visual indicator. So I'm going to plug this in. And I'm going to grab my Swiss on, which is already over here. I'm going to plug it into my face, and we're going to focus right here on the DMX. So what you will see, come this way, on your 3-pin, there is an LED right here. So as I turn power on, I have to hold the trip switch. You'll see it starts flashing green. That's telling me that I have good DMX and that the controller is receiving it, and there's no issue there. If I remove my Swiss on, it goes red right away, and it'll continue to stay red until I power cycle it. So as you are troubleshooting or as you're going through, please be visual, use the LEDs as a reference, and ensure that, I'm going to do a power cycle. When you plug it in, as far as your DMX goes, that it's solid green. If you get that solid green, you don't have to guess if your 3 pins connected right. You don't have to guess if the DMX packets are getting to where they need to get to. You know for sure the controller is already doing that for you and saying, okay, I've got good DMX there. So this is D18, dial 18. This will tell you exactly how your DMX is responding. Now, there is no reference on the outside besides the DMX indicator here. However, it is not as accurate with proper packets and everything, making sure that it's actually all there and properly packaged as this LED. So please use this LED reference if you're troubleshooting any DMX there. Now, moving forward to the DMX, we're going to stay here to the DMX IO board. So this DMX IO board, we have our DMX input that we just mentioned. We also have the trip switch, or excuse me, 3-way switch and our RF link button. But this is what I want to make you wary of, is our power. Without this whole DMX section, whether it's hardline DMX or wireless DMX, it will not power up. So this connection goes over here. This is our 5-volt
connector. It is labeled J6. This is all in the notes that I gave you. So you can see here, 5 volts and ground. The orange connector, the orange wire should be on the 5 volts section of this 2-pin connector. You are only getting the positive of that DC voltage from this 2-pin here. So please, if you have DMX issues, you're not getting any DMX, you're not getting any wireless, check your 3-pin DMX and make sure that you actually have power going to the DMX idle board. Otherwise, you may your controller may be flashing saying, yeah, I got good data, but it's not going anywhere because this little board here is not getting any power. So this is your connector. If you wanted to use one of the ground references and then meter the DC voltage here and make sure you have 5 volts DC. So from your negative to this positive connection, you should have 5 volts. And if you don't have 5 volts measured here, go back to the initial connection. You can remove this 2-pin. And then you can meter directly on the 2 poles right here to make sure that you have that 5 volts. It should always be present. All of these are always present. None of these are switchable. So at all times, you'll see which one's the positive, which one's the negative, which one, it should tell you which one's 5 volts and which one's 12 volts. So just be wary that they're always on. They should always be supplying that voltage. And if you're ever in question about, is this actually being supplied, remove the connector and check the actual pins itself, because the connector is another failure point. Remember, we have crimps, we have wires, broken strands, anything could happen. The wire could be broken halfway through, it got pinched as it was getting closed up. So be sure to check your 5 volts and make sure that it's present right there on that 2-pin. Okay. The next thing we're going to go through is channels marked BO, or I'm sure NFG, or all the other things that crew love to write on each channel. Channel specific issues are a little easier to troubleshoot, in my opinion, because you don't have to guess, that the controller is working. Obviously, 11 out of 12 channels are working. So we know that the controller is functioning properly. It's just a matter of a specific circuit having either a disconnect, a fault, or something along those lines. So what I like to do is basically go through and check the flow as we did earlier for each channel. So if I go to channel 1, I want to know what's the first connection point. Well, it's the breaker. The breaker is my preliminary protection. How do we check the breaker? Check continuity. Okay, so I go to channel 1, continuity is there. Okay, I know the breaker is good, current is flowing. The next point of connection is through the choke to the relay. Now, the easiest way you can just check the choke is get continuity and meter that from your point here where the relay connects. This is your relay connection. This is coming directly from the distro block. So this goes to through your inductor to your relay. So what you want to do is put 1 meter point here and then come around to the other side and meter the bottom portion of the relay itself. So since this is channel 1, I'm going to go continuity from the breaker through the choke to the relay and make sure that it's actually making it to the destination, which is this tab on channel 1. So I checked that. Okay, continuity is good. That means current has the opportunity to flow to the relay. Now the relay, I remember I mentioned, is going to be the most common troubleshooting area. So now that we know that current is available to go to the relay, we want to make sure the relay is doing what it's supposed to do. How that works is through this ribbon cable, like I mentioned earlier. So what happens is when the relay is at, or when the DMX value is at 0% for channel 1, this would be connected like so. Channel 1 would be red and black. That's my DC connection here. Channel 2 would be red and white. So what I want to do is ensure at 0% DMX value, no DMX, I'm going to set my meter to DC voltage. I'm going to probe these 2 connections, and I'm going to ensure that there is 0 DC voltage. If I bump to 100%, because I want to make sure it's functioning properly, when I hit the bump button for channel 1, this should bump all the way up to 12 volts DC. Now, if I am at
50% or so, just so you guys understand how this works, this would read around 6 volts DC. It's not going to be right on the dot 6 volts, but you kind of catch my drift how it works. From 0 to 12 volts is going to dictate how much the relay opens or closes. So this is going to allow you to understand, okay, the relay has the connection. It's definitely got the opportunity because the wires are going from the input to the output without any resistance. And now you're just double checking that the control side, which is your DC voltage, is working properly. So if I meter this at 0% DMX value, I should get 0 volts. At 100%, 12 volts. About 50%, around 6 volts. So that's how this works. Now, if it did not get any voltage, you'd want to trace that control harness all the way back to this connector here. And this is where the voltage is being supplied. Now I can send a wiring diagram to everybody and you can go ahead and figure out which pins are red, is the red positive, and which pin is the negative terminal per channel. And essentially what you would do is the same operation you did here on the 4-pin. You would just bump that channel and ensure that the voltage is present on the connector itself over here on the controller. You need to zoom in on that, Zenia?
I cannot.
Oh, you got wires. So this would be the supply of the DC voltage before it goes to the 4-pin. So I'm going to send the wiring diagram because it's going to be really hard to see on camera right now. But essentially what you would do is you would take the red pin number 1, which is your positive, and figure out which channel is the channel in question, and then just meter there to ensure you have the same 0 to 12 volts, depending on whatever DMX you are supplying. Okay, moving on. How are we on time? We're almost on time. All right, so we have checked the relay. We want to make sure we know that the relay is connected. We know that the connections are good, the breaker is good, the relay is connected, the DC voltage is there. The last thing would be the receptacle itself. So as I mentioned earlier, where's my receptacle? There are color coding. There's a color coding on the back of the receptacle. Your line will always be gold. Your silver will be neutral. Now, if you notice on our receptacles here, we have independent line connections and 1 neutral connection. So these neutrals per duplex are shared. And what that means is this tab here on the neutral side of the receptacle should not be broken, this little metal tab. What we do in the manufacturing process is we break the line tab. Here it's still intact, but what you would see essentially is a broken line tab. Let's see if we can get a view of that right here. So as you notice, this one is broken and this one is not. So what that allows is for independent control of your channels. Now your neutral side, as I mentioned, will be connected, but if for some reason they accidentally broke that and they still wired it up the same, where it's only 1 neutral per receptacle, then the side of the receptacle that isn't getting that neutral connection will have no output. So that's another reason why you might have a channel specific failure, is the Edison itself or the socketex is having some type of disconnect, which in this case would most likely be the tab is broken, so it doesn't have a neutral connection. So be sure and be wary of that. And the last thing I want to touch on is no wireless, another common issue. So what we mentioned earlier is the wireless section here is reliant on this 5 volts DC. I already went through on how to check that. You would essentially either turn the unit on, hold the trip switch down, or tape it down, and then measure that you have 5 volts present here. And if you did, then you might want to check the DMX connection to make sure your signal's going there. If your DMX is good and your power is good, the only other thing that it might be is the 3-way switch itself. So I have a 3-way switch that I have outside of the unit. And how that works is, this is actually a 2-way switch, but same type of setup. When I flip it up to receive, what it does is it makes a connection. This would be my 5 volts in the center, the brown wire. And then this would be my receive function, so my negative for that. What I do is if I flip it up, it connects these two and turns on the wireless card and gives you the 5 volts in receive mode.
If I flip it in neutral, it turns it off. If I flip it down, it'll connect these two and give you your transmit function. Now, obviously, if the switch is broken and it's not able to switch back and forth, then you will never get wireless engaged. So you might have proper voltage here, you might have proper DMX, but the switch itself is broken. And the easiest way to check that is with your meter continuity. So you want to make sure that when the switch is flipped up, the bottom and the middle tab have continuity. When the switch is flipped down, the top and the middle tab have continuity. And this will ensure that the three-way switch is enabling and disabling properly and allowing you to have function of your wireless control.
That is a very basic. I can probably go into this for another few hours, but a very basic overview of what you might see when the dimmers come back for repair. I try to type up as much as I can. I'm going to elaborate a little bit more, add some pictures, include wiring diagrams. So please take a look at the sheet that I gave you, make your notes. Email me if you don't have my email. I will put it in the chat, and then request whatever material you want. If you want follow-ups, I am always doing Zoom training, even if it's one-on-one, like, hey, I took your class, I understood most of what you said, but can you elaborate on this or that? I have no problem doing that whatsoever. In the meantime, do we have any questions?
No questions.
No questions yet? Do we have time? We don't really have time to get into the three-phase dimmer, but I want to give them a quick view. We can't get into it too much, but a lot of what we covered is essentially the same thing that's going on here in the 24 by 1.2. So what we have is we have our input. We have your cam lock input. 2-gauge wire. Remember, we're dealing with 3 phases instead of 1 now. So instead of a Bates with 3 pins, line, neutral, ground, now we have cam lock. So each line, black, red, blue, is its independent phase. So as I mentioned earlier, we have our distro block here. I'm going to flip this up. And our distro block is distributing each phase to each of the channels. So as you're servicing our 3-phase dimmers, understand that the way we do our wiring is channel 1 is going to be A phase. Channel 2, that's kind of hard to see from there. So channel 1 is going to be A phase. Channel 2 is going to be B phase or red. Channel 3 will be blue or C phase, and so on. So it's A, B, C, A, B, C, A, B, C. Now, there are times where a phase can go out, and I'll immediately know because channel 1, channel 4, channel 7, channel 10 will be dead, so on. Every third channel will be dead. That tells me it's a phase-related issue. So one thing I want to check is to make sure that the connection here is still good. Usually that's not the case, but of course you want to check it. The breakers will most likely not be the case if it's multiple channels on the same phase, but of course check your breakers. And then the same process goes through your choke to your relay. Your relays are wired up the same exact way. However, the controls are now here. So you have 3 separate controls, 8 channels each instead of 6 as a single phase does. And then you have, what's important is you have phase specific breakers on the face. Okay, take a look at this, Senya. These are one of the older packs. However, they're all going to have phase specific breakers. And what this means is this is tied in directly to your brain. So when you plug in your cam locks, all 3 of these should illuminate. If one of them is out, you can pull out the fuse, check it with continuity, pop it back in. Our newer packs have panel mount fuses, so you would just remove it, check continuity. You can probably check it with still installed, and then pop a new one back in. Because what will happen is if this is popped, then the whole phase, an entire phase will not be supplied by the controller because it'll be dead. So if you have a phase specific issue, check that fuse. Just like the other controller, here's the 9-pin power input. Take a look at this thing right here. So here's the 9-pin power, just like we had on the 12-channel controller. However, instead of one black and neutral or line and neutral, now we have multiple. So we have A phase, black, line, neutral. We have the red line, which is B phase and neutral. And then we have blue, which is C phase and neutral. And then this is output for the fans, just like the 12-channel controller, slightly different. One thing that is mainly different on these 20-inch packs is there is a power supply. So this power supply right here, I don't know if you can see it under these wires.
there is a power supply that supplies 12 volts DC to the back of this backplane board right here. So this is 12 volts DC. If you don't have the AC input and the 12 volts DC, then you will not have any operation control of this dimmer. And how quickly, because I know we're pretty much done here, how the power supply works is it works off A phase. All of our electronics on these 3-phase controllers work off A phase. So if your A phase is out, your brain won't turn on, your power supply won't turn on, which means you won't get 12 volts to the brain and you will have no control whatsoever. So if you want to quickly check the power supply, you come right here on this side. Here is my A phase input, my neutral, and then here is my DC output. So you should have 12 volts DC on this side and then 120 AC on this side. So I have AC coming in, DC coming out, going to the backplane board, and the backplane board itself that is on the controller, which is right here, needs to have 120 between the line and neutral for each phase. So black and white, 120, red and white, 120, blue and white, 120, and then 12 volts DC here, and the same little brown fuse that the 12 channel controller had is right here next to the line and just like it was on the 12 channel. So keep that in mind. As far as everything else goes, it looks different, but it essentially is the same exact circuit layout that I went through earlier. That's pretty much the time that we have. I know it was very brief. I hope the notes help. I am always willing to teach a little bit more, even if it's a Zoom call one-on-one. We will be putting a lot more of training material together. So what the goal is to have a QR code, essentially like a business card, to hand out to all of our technicians across the country and out of the country, as well as customers, to be able to access our bundle. It's going to be a tech bundle. It's going to have wiring diagrams, troubleshooting guides. Ratpac Control's YouTube channel is a great source as well, a resource for all of our training materials. So please check that out and reach out to me personally. Xenia, if you would put my email in the chat. Cool. And then, yeah, just reach out to me and I can give you anything that you need in regards to troubleshooting and training. Did we have any questions?
No questions? Nope. Still no questions.